Hello and welcome to the Rise of the PyWomen series. In these 30 days, I will show you real data science and machine learning tips and tricks. I am Manya and my mission is helping decision makers gain more profit with machine learning insights. So let's get and learn together. See you inside. Hello everyone and welcome to another episode of Rise of the PyWomen. On this vlog 6 today, we will cover 3D plots. 3D is likely sophisticated, but it's very straightforward as 2D. We will use Matplotlib to make 3D plots. I will show you how to make it in this tutorial. We need first to import our libraries. So let's go and import our libraries. So let me see. Okay, so let's go and import it. So first import, of course, matplotlib dot pyplot as plt. Then we want our plots to be in line so that they can show in the Jupyter notebook. So it will here. This will help us do that. And then from MPL lower toolkits dot mplot 3D import access 3D, no D, 3D, and then import numpy for generating numbers, so numpy as mp. So this library mple toolkits, it uses for us it's for making this 3D plots. So let's go and run this. And our first today plot, it will be a line. So first of all, I will go and make this line plots. So I will write a code, and then after that I will explain you what I did. So first we have to, of course, to import our library. So we will import matplotlib as MPL. Then from MPL lower, okay, MPL toolkits dot mp plot 3D import access 3D import numpy as mp and import matplotlib pyplot as plt. So that's our library. So now we have to define our parameter. So mplc params box brackets legend dot font size equals 10, flg equals plt dot figure big size equals in the bracket 10 by 10, then okay, so axis equals GCA in brackets projection equals 3D, and then theta equals np lin space in the brackets minus 4 np.pi 4 5 np.pi, and then 100. Z equals np lin space in the bracket -2 2 and 100, and then R equals Z double 2 plus 1, and then X equals R multiplied by np dot sinus theta, and Y is the same but cosinus, so equals R multiplied by np dot cosinus theta, and then we have axis plots in the brackets, so X, Y, Z label equals parametric curve, X legend show, and plt dot show. Okay, and then we will run this. So what I did here, so it's in the line 8, so for the sorry, my mistake. Okay, now it goes. So let's explain what this curve and how we got it. So first of all, as I said, we import libraries, so we needed these libraries in order to get it. Then we defined our MPLRC parameters. So we want our font size to be, for the legend, you can see for this, to be 10. Then we wanted our figure to be 10 by 10, so you can see it's 10 by 10, so 10 by 10. So all our plots will be 10 by 10, so 10 by 10. Also our projection, so this is why it was the difference between 2D and 3D. So our projections for axis is 3D. Then we define our values, so our theta, x, z, x, and y. So we can see that we set the legend size to the font size, as I said, 10 to 10, and then you can actually see what's right in here. So parametric curve. Then so is for the label, so we have the label, so we can change it into be something else. So we defined our parameter values, so z, x, and y, and we at the end x, y, z we plot it and we show it. So now you can see that we have that we have a spiral line curve, and it looks really nice. So our next step is scatter plot. So scatter plot, it's actually the same as the scatter plot we can make in 2D. So the difference is only in the one line of the code. I will also, as in the previous example, I will first write down code, and then I will explain what I did and why I did, and we will see how scatter plot looks like. So let's go. Defined rand range and minimum max return in the brackets run max minus run min multiply with np random dot rand in the brackets n plus run min, then figure equals plt dot figure. So figure equals plt dot figure, and then fig size equals in brackets 10 10, axis equals fig dot add subplot in the 100 projection equals 3D, and equals 100 for C M ZL and ZL ZH in R O and then -50 and then -25 comma another bracket, so B, so blue, so for the this is for red and blue, okay. And it's defined with -30 and -5, okay. And this, so xs equals rand range bracket n 23 32, so ys equals rand range equals n 0 100, zs equals rand range and ZL and ZH, and axis dot scatter in bracket xs ys zs, and color equals C, and marker marker equals M. Then we have axis set x label in the bracket x, and same for y, so x dot set y label, then y, and for z the same, x dot set z label z, and of course plt dot show and brackets here, and then show it. So this is our scatter plot here. So let's briefly explain what we did. So So over here, I just wanted to play around with the colors a bit. So you can see that Z is from the range from -50 and -55, and our color is red, and for the blue is in range of -30 and -5. So you can see when you look at it, it's like this for the red one and the blue one. And also after that, like, I defined our x, s, y, s, and z, zs. Keep in mind that these numbers are random. I just using the random for this example. Then I have this axis scatter, so it is the same exact as a scatter as you see in 2D, but I'm using, as you know, 3D projection, so that's the only difference. Then my colors are equal to C, so color is equal colors, and we use a marker for M. So you can also change the colors. You can choose the other ones. I just use this because I thought they were the best solution. So label XYZ becomes like that because I think it's the most common label for it, because we all know about X, Y, and Z. So this is our scatter plot, and show us how scatter plot looks like. So our next section is wireframe. I will also write down a code for the wireframe, and then I will explain what I did. So let's go from npl toolkits .mp plots 3D import axis 3D, then fig equals plt dot figure, fig size as I done it in the previous, so my fig size equals 10 by 10. Then axis equals fig dot add subplot one, projection again equals 3D, and then we have x, y, z equals axis 3D dot get test data, and you can say 0.05, and x dot plot wireframe stride. So first x plot, so x, y, z, stride equals 10, and c stride equals 10 as well, and then we have plt dot show, of course, and let's run it. So sorry, so here is wireframe, my mistake. So you can see now a wireframe. So what's the difference between wireframe and these other plots that we made? So you can see that this is a lower cases. So notice that like 3D and so D and A are in the lower cases instead of as usual upper cases for the 3D axis. So the lower cases is basically a database of data points you can play around with. I just get tested up a number point of 0.05. You can also use another number. So I just chose this for this data set because I thought it's the best one. Then I plotted, as you can see, x. So I plotted x, y, z, z, because I got x, y, z values, and then have our R stride and C stride, each equal to size 10. There are our row and spacing and column spacing, as you can see here. So row and column spacing, as you can see here, for the wireframe. And of course, so for my so that's like the basic stuff what we did here to make this wireframe plot. And our next stop is surface. So this will be the last thing that I will show you today. Also, you can go and download my my code on the link on my GitHub, and you can see other plots that I made. So contour, you can see it's really a nice. Also a polygon, and you can make a bar even, and you can make keyword. So there are a lot of also more plots using Matplotlib, but I just choose these couple of them to show you. So for today, so we will finish the surface, and these other ones will be your homework. So let's go and do the surface. I will do the same stuff that I did in the previous section. So I will write the code, and then I will explain what I did. So fig equals plt dot figure, and that equals, again, fig size equals 10. So we use 10 by 10 for every of these examples. Then axis equals fig dot add subplot in the brackets 1 1. Projection again equals 3D, and then np dot linspace. And then we have u equals np dot linspace in the bracket 0 2 by np dot pi, then 100, and then we have v. So v equals np linspace in the brackets again 0, then np dot pi, and then 100. So that's our values u and y, and then we have x, y, and z. So x equals 10 multiplied by np outer, so it's for the outer source, so outer, and then np dot cosinus in the bracket u, and then comma np dot sinus in the bracket v. And for the y we have 10 multiplied by np, again outer, so this is for the outer of the sphere, of the sphere, or of the circle, you can say. So np dot sinus u, and then np dot sinus v, and then we have here z equals 10 by np dot outer, np dot once, so np dot no, it's np outer, yeah, and then np once, and we have to add here one more, so np dot size in the bracket u, then mp dot cosinus in the brackets v. So we have 10 multiplied by mp outer in the bracket mp once in the bracket mp size u e. So we will close here the bracket, and then mp cosinus, okay, and then we have x dot plot surface in the brackets, so in the brackets x, y, z, and again r stride equals 4 and c stride equals 4, and then color can be, for example, blue. Okay. And then plt dot show, and we can plot it. So you can see now a sphere. Also we can do here, we can change again like the color, maybe in the red, and we can like change here, for example, we can say here cosinus, and then we can show it again, and you can see it definitely changed. So it's really important to know which parts you have to add. So you can see if I change the cosinus, you can see that this no more isn't sphere. So now I will go back to the sphere. So you can see now it's a really nice red sphere. So surface. So let's say what I did here. So for my surface plot, exactly is the same as the previous for wireframe. So we can see I again use a projection 3D. Then I plot x, y, and z on the plot surface. So, and then I add r stride and c stride as 4, and also as usual my color is as first was blue, then I change it. So you can like just play with this, so you can see why you need to use cosinus and sinus here. You can see why are they important, because if you saw it when I did it, you can see that when I changed the cosinus here, then we didn't cut the circle above the surface. And that's it for today. Also, like you can see on my GitHub, so go there and download this Jupyter notebook. You can see that I made a lot more. So I choose like contour, so you can see how it looks like, and then after that I made a polygon. You can see also, then I made a bar chart, and again I made a quiver. So that's it for today. For this other, please download the dataset on GitHub, or even you can subscribe to my email list, and then I will send you a dataset and the codes to you. That's it for today. Thank you so much for being part of my data science journey. You can share and like, and also share with someone from the data science world. Until tomorrow, happy whizzing!